Now, sometimes you're given information in critical thinking problems that you got to find an answer to, and there's not one formula that fits all the parts and pieces you have given. So what you have to do is take some of those parts and pieces, put it in one formula and get a value for that, so that you can then substitute it into the other formula with the additional information you had given to answer the question. This happens a lot of time if you're in electronics. It happens a lot of time if you're dealing with management type problems that deals with business processes that you get involved with. Particularly if you're talking about amortization charts, you're talking about compound interest type problems and things like that. So those of you that haven't taken any of those management courses yet, yes, you will be manipulating formulas. Okay? So just because you're doing that in this math class and you walk out of here, don't think you won't ever see it again. You will. It may not be the same formula, but the process is going to be done the same way. So on page 70, as you're looking at some of these problems, let's see what we would have here. Number 32, for example, you've got C is equal to 2 times pi times R, and they ask you to solve this formula for R. Now, you're going to do it, like I said, the same way. If you're solving this for R, how many terms do you see?
2.
Through the whole thing, how many terms do you see?
4.
There are 2 terms. What are terms? Written as products or quotients.
Yes.
Separated by addition and subtraction sign. In this case, we got one term on this side and one term on this side, which is 2 terms. So all of this is written as a product, multiplication. So if I'm going to solve it for R, I've got to get R by itself, just like when you solve the equation for X. You get X by itself. How did you do that? The last step you followed was to divide both sides by its coefficient. So if all of this is multiplication and I want to end up with 1R, then I've got to take this and divide it by everything that's being multiplied times that R. And if I do it on this side, I've got to do the same thing over here. This divides evenly, giving me 1 times R, which is R, and now I have it C over 2 pi. Okay? That's solving it for R. Number 34, what you have in that one is the following. You have V squared is equal to V sub O. A number written down here is called a subscript. That's to tell you that that V is representing something totally different from the others. Okay? If they have different subscripts, they're different values. That's V sub O squared plus 2AX, and you're going to solve this for A. Okay? You're solving it for A. Okay, how many terms do you see in this one?
3.
3. We want the term that has the A in it by itself. So what do you got to move? V sub O squared. Okay? It's added, so to do the moving, we do the opposite, which is subtracted. Subtract V sub O squared from both sides. Now, a V and a V sub O are not like terms. So I have to bring down my V squared and subtract V sub O squared. Bring them both down, V squared and this one. Now on this side, they add up to 0, and I have left 2AX. I'm solving for A. How is the 2 and the X related to it? Addition, subtraction, multiplication, or division?
Multiplication.
Multiplication. So to get A by itself, you do the opposite. And if the only thing I want over here is A, I divide both sides by 2X. The 2's divide out, the X's divide side out, and I'm left with an A. None of these are like terms, so I cannot combine them. They all have different variable representations, so when I get to this step, I am through. Any questions about that one?
Why did you get rid of the these two over here?
Which one? This
Next
one?
one, that.
This one? How can I get rid of it?
With those two.
This one's a V sub O. That means it's different than V. See, that doesn't have a zero there. It's just a regular V, and this one's V sub O. That means they represent two different things. Okay, they're not like terms. To be like terms, the variables have to be identical and the exponents. Okay? All right, look at number 35. You have A is equal to 1/2 capital B plus small letter b. Here again, they're not the same thing. Times H, and you're to solve for capital B. Okay? All right, if you were doing this and you had numbers and letters in there, and the letter you're solving for is the B, follow the order of operations, just like you normally would. Can I combine anything in here? No. So then the other thing I've got left to do is to see what's outside the parentheses. Well, I got a 1/2 in front of it, and I got an H behind it. Is there any operation between the parentheses and that 1/2, or the parentheses and the H? No, so that means it's multiplication, doesn't it? So before I do that multiplication, I'm just going to bring it up here together. Makes it a little bit easier to see what I'm doing. Okay, can't combine like terms here. Both of these are being multiplied times the parentheses, so I just combine them up there together. Do your distributive property. 1/2 H times B is 1/2 H capital B. 1/2 H times lowercase b is plus 1/2 H lowercase b. And that's equal to A. All right, you got those fractions there. What are you going to do? And this is 2. So I'm going to say 2 times this. I got 2A. What do you get when you say 2 times 1/2?
1.
You get 1, because it ends up being 2 over 2, which is 1. And 1 times HB is HB. I got 2 times 1/2 again. That's going to give me a 1 times H lowercase b, so it's H lowercase b. Now what are we solving for?
B.
I'm saying 2 times this, 2 times this, and 2 times that. That's what I'm doing there, okay? All right, we're solving for capital B. So this term we got to get by itself now. So what have I got to move? Okay, the H lowercase b. So I subtracted, as you said, from both sides. Over here, that adds up to 0, and I've got H capital B left. Now, these are not like terms, because each one of those variables represents something different. So I got 2A minus HB. Now, what am I solving for?
B.
So what do I do now? Divide both sides by H. So I've got 2A minus HB divided by H. And I've got, that's equal to HB divided by H. That goes out giving me B. And over here, you don't have to do any more. Okay? Any questions about what we just did? Yes.
If you're subtracting both sides by H, would
No.
that not get,
Right here?
yeah, well, you divided that by negative H, so you got rid of them and brought the B down. On the other side of the equal sign,